Okay, so a summary of the exponent rules that we have. We already talked about before the product rule. When you multiply the same base, then you're going to keep that base and you're going to add the exponents, right? The power rule, if you have a base raised to a power raised to another power, multiply those powers together. Quotient rule, if you're dividing the same base, keep that base and subtract the exponents. It's always the numerator exponent minus the denominator. Product to a power, if you have a product raised to a power, then each factor of that product gets that power. Quotient to a power works the same way. A quotient raised to a power, each part of the quotient gets the power. The numerator gets that exponent and the denominator gets that exponent. The zero exponent rule, my favorite. Any base raised to the zeroth power is just 1. And the negative exponent rule, now we add to our list. Any base raised to a negative exponent equals 1 over that base raised to a positive of that exponent. It just flips that base over a division bar so that it is a positive exponent. So let's use these rules to simplify an expression by writing this with positive exponents only. There are many rules that we're going to need here, and we can start with any of them that we want. I like to start on the inside before I worry about the outside. So let me look in the inside. I've got negative exponents, I've got quotients. Let me just do the quotient rule first. Okay, so inside of this negative 2 exponent for everything, I'm going to look at the quotient rule. So 3 to the negative 2 divided by 3 to the negative 4. I'm going to use the quotient rule. So exponent of the numerator minus exponent of the denominator. Now base A, I'm going to take numerator exponent minus denominator. And base B, the numerator is a 1 since it doesn't have an exponent. And I ran out of space here. Let me move this. I'm going to subtract the negative 3 exponent from the denominator. Okay. Let's simplify what we have in here. So that's going to be negative 2 plus 4 by that general rule. And negative 2 plus 4 is 2. Base A, 3 minus 7 is negative 4. And base B, that's going to be plus 3 by the general rule, so to the 4th. All right. Now I'm going to do a product to a power. I'm going to give that negative 2 exponent to every factor in the base. So 3 squared to the negative 2, A to the 4th to the negative 2, B to the 4th to the negative 2. Then I've got a bunch of power rules. So base 3 will multiply the exponents. 2 times negative 2 is negative 4. Base A, if we multiply, negative 4 times negative 2 is positive 8. And base B, 4 times negative 2 is negative 8. All right. Now, any negative base, I cannot keep that in my final answers. So negative exponent. Any base with a negative exponent. So the 3 is going to shift over a division bar, and the B is going to shift over the division bar. So the A has a positive exponent. It does not go anywhere. It stays in the numerator where it belongs. Then the last thing I need to do is I can actually evaluate 3 to the 4th power. 3 times 3 is 9 times 3 times 3, so that would be 81 if I simplify that exponential expression there. So that would be the simplified expression using the exponent rules, and you can do this in a different order, but we should come out with the same answer there.